Bismillahir Rahmanir Rahim. Hello and welcome to a new lesson, my dear and esteemed students. Lesson number 8. And the title of this lesson will be Sinking and Floating. And this lesson, lesson number 8, is a specialization lesson for scientific section. So here you have to draw your attention carefully if I want to give you some expressions related to scientific fields. We will talk about sinking and floating, and sinking is the opposite of floating. Sinking means drowning in water, and floating means to float on the surface of water. Let's begin. Number A. Underline the objects in the box which are buoyant and can float in water. Here we have some objects like a gold block, a cork, ice, sand, a piece of wood, polystyrene, a stone, concrete, an empty can, a submarine, and finally we have a coin. Some of these objects can float on the surface of water, whereas the other objects sink or get drown in water. Now, after looking and knowing the meaning and the substance of these objects, we can decide if they can sink or float on the surface of water. And here are the answers, my dear students. The answers. These objects can float in water. So these objects can float in water: a cork, ice, a piece of wood. So most types of wood can float in water: polystyrene, an empty can, a submarine, and the others don't normally float in water. So the other materials don't float in water, they sink on water. So here are the objects which can float in the surface or on the surface of water: cork, ice, piece of wood. So most types of wood can float on water: polystyrene, an empty can, and a submarine. After doing this exercise, let's do another task, another exercise, my dear students. Number B. Work in pairs. Check your answers in exercise number A and then discuss these questions. Here we have 3 questions to be discussed. Number 1. Why do some objects in exercise number A float and others sink? Here we want to know the reason beyond sinking and floating objects. Number 2. Why do even the heaviest ships float in water? So we can see some ships which weigh about 1,000 tons. They are so heavy, but at the same time they are float on water, on the surface of water. So why do even the heaviest ships float in water? They don't sink in water. Number 3. What do you know about Archimedes? What do you know about Archimedes? Have you heard of Archimedes principle? So here we have a principle belongs to Archimedes. We want to know this principle. Have you thought of the answers to these questions, my students? I think you have done. And here you are the answers. So why do some objects in exercise number 8 float and others sink? The reason is their density. Here we are talking about the density of any material. So their density is all less than the density of water. And if their density is less, then that means they can float on water. They can float on water. And the density of water, 1 cubic centimeters of water at 4 degrees Celsius weighs 1 gram. This is the density of water. And if any material has a density which is less than the density of water, it can float. But if its density is more than the density of water, it will sink. Number 2, why do even the heaviest ships float on water? Here, even the heaviest ships float on water because their weight equals the upthrust of the displaced water. Because their weight equals the upthrust of the displaced water. And what is the meaning of upthrust? Upthrust is the force which push something. The force which pushes something upward. And finally, we have, what do you think about Archimedes? He is a scientist, but have you ever heard about it? And have you ever heard of Archimedes' principle? So I am sure you have heard about Archimedes. You are great students, and I am sure you have heard of him. Now number C, the answers to the questions in exercise number B were discovered 2,200 years ago by the Greek inventor and scientist and mathematician Archimedes. So Archimedes was an inventor and a mathematician at the same time. Read the text and check the information about Archimedes and his principle. I am reading now. You fill your bath with water. What happens when you get in? The water rises. It's displaced by your body. One day, while getting into his bath, Archimedes noticed water spilling over the sides. Suddenly, he understood that relation between the water that had fallen out and the weight of his body. In other words, he had discovered why some subjects float and some sink. Archimedes worked out that the key to buoyancy is how much volume an object displaces compared to its weight. Archimedes' discovery, now called Archimedes' principle, explains why steel ships weighing thousands of tons float. When a body is immersed in water, it experiences a force known as the buoyancy force. And this force is equal to the weight of the water displaced by the body. For example, a lump of steel will sink because it can't displace water that equals its weight. but still of the same weight, shaped as a ball, will float. And this is because the weight is distributed over a larger area, and the still displaced water equal to its weight. So a ship with thousands of passengers or a heavy cargo floats because its total weight is exactly equal to the weight of the water it displaces. It's this weight that exerts the buoyant force supporting the ship. After reading the text, we can do number D. Complete the sentence using the information from the text in exercise number C. An object will float in water if, here we have a conditional sentence, and we have to fill in the space or the spaces here. An object will float in water if the weight, so here, if the weight of the object equals the upthrust of the displaced water. And as I have said, upthrust means the force which pushes something up in water. And you can see now the answer. So an object will float in water if the weight of the object equals the upthrust of the displaced water. Now, number E, work in pairs and discuss these questions. Why can you float in water? And why is it so easy to float in the Dead Sea? We have two questions. Number one, why can you float in water? What's the reason of floating what is the reason for floating in water? And why is it easy to float in the Dead Sea? So floating in the Dead Sea is easier than floating in other seas. You can brainstorm your head, my darling. You can think deeply. And here are the answers. Number one, the reason behind floating our body, for example, our bodies in water is the overall density of the human body is normally less than the density of water. The overall density of our bodies is normally less than the density of water. So, eventually, we can float. Number two, the Dead Sea. Yeah, why is it so easy to float in the Dead Sea? Why? Because the Dead Sea has a high salt content. As you all know, its water is salt. And it has a high salt content, and so it's denser than fresh water or ordinary seawater. As a result, people can float easily in the water because its density is more than other seas. The Dead Sea has a high salt content, and so it is denser than freshwater or ordinary seawater. As a result, finally, people can float easily in the water. Now let's do exercise number A in your workbook, complete the paragraph with words from the books. We have 8 words and 8 spaces. Number 1, density. Number 2, equal. Number 3, much. Number 4, float, water, sink, less, and high. Here we want to read the paragraph and put the correct word in the space. I am starting reading. Whether an object floats or sinks in water depends on its density. A block of gold, for example, has a high density. A high density, yeah. When it's placed in water, it will sink. It will sink. Polystyrene, however, has a much lower density. Yeah. The weight of a block of polystyrene is less than the weight of a block of gold with the same volume. That is to say, it has a lower density. It has a lower density. The density of a block of polystyrene is less than that of water. So when a block of polystyrene is placed in water, it will float. It will float. And finally, the upthrust of the water displaced by the block is equal. So the upthrust of the water displaced by the block is equal to the weight of the block. After filling in the spaces, we can see the answers to check them. Now, my dear students, you can compare your answers with these answers in front of you. Number A, number 1, high. Number 2, sink. Number 3, much. 4, less. 5, density. Number 6, water. Number 7, float. And finally, we have equal. We have equal. Now, number B, complete the formula for the measurement of density. Here, if you want to calculate or if you want to measure the density of any material, any substance, we have a formula to do that. And here we want to know this formula, so we are asked to complete the formula for the measurement of density here. Then answer the questions. Density equals what? Yeah, density equals weights divided by volume. Weights divided by volume. Gram on cubic centimeters. Yeah. A block weighs 200 grams. It measures 4 centimeters multiplied by 4 centimeters multiplied by 5 centimeters. So here we have a block. Its weight is 200 grams. And here we have the measures 4 centimeters and 5 centimeters. What is the volume of the block? Now let's calculate, let's measure the volume. The volume is 4 multiplied by 4 multiplied by 5 equals 80 centimeters. Equals 80 cubic centimeters. What is the density of the block? Here the density is the weight divided by the volume. What is the weight? The weight here is 200. So here we want to divide, we want to put 200 divided by 80. and the answer is 2.5 gram on cubic centimeters. Will the block float in the water? Why or why not? Yeah, here the answer is no. It doesn't float in water because the density is greater than that of water. Because its density is greater than the density of water, so it can't float in water. It doesn't float on water. See, so here the volume of the block is 80 centimeter. The density of the block is 2.5 gram on cubic centimeters, and no, the density is no. It doesn't float because the density is greater than that of water. Now we can conclude our lesson by doing this exercise. My dear students, I hope you a good future, but if you want to have a good future, you have to study hard. You have to do your homework perfectly. You have to do your best and all your duties. Finally, I want to thank you for listening to me, and goodbye. Goodbye.